Okay, so the first one you have to do is you have to do the drawings. So what I would do, since you guys know how to balance now a lot better than when we first went through this, what I would do is I would balance it. If you notice, you got a 3 and you got a 2 for chlorine because aluminum is balanced by sight. You realize that you have to get those both to 6. So you put a 3 in front of Cl2 and a 2 in front of AlCl3. Then all we have to do is balance out the aluminums. So when you do that, you'd have to do 2 drawings of aluminum chloride, trichloride. So you got 3 of these. And that's what you would draw to get all the points. Then you got your arrow and then you draw 3 chlorines. Make sure they connect. So they're diatomic. Chlorine's diatomic. Ends in I and E. It's one of those that would be diatomic. And then you got 2 aluminums. And that's it. That's what you would do for the first one. Second one, again, I would balance it. And so you got oxygens, you kind of leave at the end because if you notice over here, you got 2 oxygens and you kind of like, hey, I'm going to wait and do those at the end. So carbons balance. They look to be balanced out. Hydrogens are not balanced. There's 4 here, and over here there's 2. So I need to put a 2 in front of that. And what that does is it gives me my 4 hydrogens. And now I look at oxygen. Over here I have 2. But then over here I have 2 oxygens here. And I have 2 oxygens here because that multiplies through that front number. So that's a total of 4. So I put a 2 in front of O2 and it gives me 4. So there would be the balance reaction for that. So then what you do is you put carbon surrounded by your 4 hydrogens. 2 oxygens drawn out. Then you would do CO2. You only have to have one of those, and in water you would go oxygen, hydrogen. And that's how you would do number 2. The next ones I'll just balance real quick. Show you. So, number 3, if you notice, aluminum's balance. Zinc's balance. We got a 2 for chlorine on the right side and a 3 chlorine on the left side. So then we'll put a 2 in front of AlCl3 so we can get the 6 value that we need to get chlorines both to. So that gives me 6 value for the chlorines on both sides. And then we just have to adjust our zinc and aluminum. So we have 2 aluminums here and 3 zincs there. And then it would be balanced at that point in time. Okay. So then we've got the next one. We can start out looking at Ba. And Ba, there's 1 here, and there's 3 over here. So barium, I could put a 3 in front of the Ba. The oxygens, we'll kind of hold off on oxygens because they look like they might be in different spots. If you notice, we go to sodium, it has a 3, and over here it has a 2. So again, guess what? Yeah, it's got to be 6. So we got to put a 2 in front of Na to make it 6. And a 3 in front of Na2 to make it 6. So now, what we'll do is we'll go to PO4. We won't break it apart, because PO4 is in 2 spots. Okay? So we look at PO4, guess what? There's 2 PO4s here, and over here there's 2. So guess what? They balance out. So we're in good shape there. And then we look at oxygens. There's a 3 in front, which makes it have 3 oxygens, and there's a 3 in front here, which makes it 3 oxygens. So we're good to go on that one, number 4. Okay, we're on to number 5, toward the bottom of the sheet. Number 5, we look at calcium, and there's 1 each. We're good to go on that one. We look at nitrate. This whole thing, this whole nitrate, NO3, there's 2 of them. All right? And over here we have 1 of them listed out. So we put a 2 in front, which gives us our 2 nitrates. Then we look at potassium, and there's 1 there, and over here there's 2. And so we put a 2 in front of potassium. So our calcium's equal, our nitrate's equal, our potassium's equal. So now, this OHs, we hope they're going to equal, because the OHs on this side, hydroxides, there's 2, and over on this side, there's 2. So they balance. So it would be 1, 2, 2, 1. Number 7. Okay, so we're looking at iron. It's 1 here and 2 here. But I kind of see out of the corner of my eye, I see oxygen, we have 2 and 3. So maybe before I do iron, I can do oxygen, because I know that's probably going to mess me up with my iron again. So I put a 3 in front of O2, and I put a 2 in front of O3, because this 2 multiplies through that 3, and then this 3 multiplies that 2, so there's 6. When we take a look at, for example, for that oxygen. So we got 3 in front, and that balances out our oxygens when we do that. Then what we have is we have 2 times 2 is 4, so we put a 4 in front and we got it balanced. So that's how you do number 7. Number 8. Looks like it could be complicated. We'll balance out irons to begin with. We're good to go. We probably won't hit oxygens because, well, I guess we can hit oxygens, I guess, next. So here we have 1 oxygen, and here we have 3 oxygens. So I'll put a 3 in front of this. And so what it does is it balances out my oxygens, and then my hydrogens become unbalanced. So I have 6 here, and over here I have 2. So I put a 3 in front. That gives me 6 oxygens, so that balances out. Okay, the next one we have is we have aluminum.
Anthony Fralin, please come to the office. Anthony Fralin, please come to the office.
So we have aluminum. These other ones I'm probably going to put charges above just to make sure. So +1, -1. Aluminum is a +3, -1. And sodium is a, well, that one's by itself, so it doesn't have a charge. So I can just write Na for that one. It's not diatomic. It's not like ends in GEN or INE. So sodium chloride's fine the way it is. It's NaCl because it's 1 to 1 equal. Now this one is +3, where chloride, each one's a -1. So I got to have 3 of those when I write my formula. So it'd be AlCl3 plus sodium. Okay, so then what we have is we're going to put 3 in front of NaCl, and my chlorines balance out, but my sodiums are 3 times as much, and over here I don't have a 3 in front of that, so I put a 3 in front of that, and that would be balanced. Next one, calcium can be written as Ca, water's H2O, calcium hydroxides, +2, -1 for OH. I look it up, so it's CaOH. So we have CaOH, and you have to have 2 of the OHs. And remember that you got to put polyatomic ions in parentheses, so you put a 2 behind it. Then you got hydrogen gas, which is H2. So the H is
Anthony Wade Fralin, please call the office. Anthony Wade Fralin, please come to the office.
okay. So what we have is H's are kind of not a good one to start out with because there's 2 locations on this side you can see, and so we just want to keep away from that until the very end. So calcium equals 1 and 1. Oxygens, there's 1 here. See, we keep away from hydrogen, H2. And over here, there's 2. This goes with that one. So there's 2. So you'll put a 2 in front of H2, and then find out with this one, the hydrogens do balance out. So that's the nice thing about this. So we realize that the hydrogens will balance out when we take a look at this example. Okay, so that would be balanced. All right, these are written out, and these are a little bit tougher to kind of work with. So lithium metal is Li. Reacts with nitric acid, which is HNO3. I told you that because you don't know. Hydrogen gas, it produces. So it produces. So hydrogen gas is H2. And then lithium nitrate is, lithium's a +1, nitrate's a -1 on your chart. So that would be LiNO3. And so you just need to have 1 of each. So then to balance that one, you just put a 2 in front of HNO3. It balances out your hydrogens. Now we have 2 nitrates. And over here we have 1 nitrate, so we got to put a 2 in front of that. And then 2 in front of lithium. So it goes 2, 2, 1, 2. Next one's nitrogen gas. It ends in gen, so that's N2. Hydrogen gas is H2. It makes ammonia, NH3. So there's our free 2. So what we have to do is put a 3 in front of this hydrogen, a 2 in front of NH3, gives me 6 hydrogens, and then the 2 N2 works fine, so that one's balanced. Okay, and then I believe the last 2 on our list, oxygen gas is O2. Hydrogen gas is H2. Produces water is H2O. So then we're good to go there. Hydrogen is good to go, 2 and 2, and oxygen is not. So you put a 2 in front of H2O, which multiplies your 2. You got 2 of those, and 4 hydrogens. So I got to put a 2 in front of H2, and it's balanced. So that would be 1, 2, 2 for that example, when we take a look at that example when it's all done. Okay? And the very last one, finally, we get aluminum bromide, AlBr. But aluminum's a +3, bromide's a -1. So that's AlBr free. It reacts with iron nitrate, iron free. So that's FeNO3, and this 3 means it's a +3 charge, nitrate's a -1. We got 2 of them. I guess we should have 3 of them. So that should be NO3 free. Then it produces aluminum nitrate, so it's AlNO3. Let's see if our charge is balanced. +3, -1. They don't. Need 3 nitrates. So this doesn't stand for 3 nitrates, but we need to put in parentheses to get our 3 of them. And our last one, we have room, is FeBr. Fe's a +3, bromine's a -1. So that's 3 of those. So it would be FeBr3. Nice thing about this, it's balanced, I think. 1 aluminum, 1 aluminum. 3 bromines, 3 bromines. 1 iron, 1 iron. 3 nitrates, 3 nitrates. Okay? So that would be the working problems of the review.